So what you're going to need is we're going to work on this page here that says model for projectile motion. And today what we're going to work on is sort of this first part. So what we have here is a little table, and we're going to do some calculations to fill in the table. And then on the next page, we're going to draw out what our calculations tell us so that we can see what path a projectile would take. And in this case, it's a rock that gets thrown off a cliff. So it says that we have discovered projectiles of a constant downward acceleration, which we did in one of those online labs. It was Free Fall 5 was what it was called. And their vertical velocity changes by minus 10 meters per second each second. So this part right here is referring to acceleration due to gravity. So that's what this guy is. Acceleration due to gravity is minus 10 meters per second squared. Then it says, a stone was dropped from the top of a cliff. Fill in the values for the velocity for the first 5 seconds. So it starts with 0 and then goes through 5 seconds of time. Use the relationship, the change in vertical position equals 1/2 times acceleration times time squared, to determine the y position at these times. And so you can simplify this a little bit further to figure out the thing that goes in the y position is going to be from this equation. But if we know that acceleration is minus 10, then this is the same as just using a simplified form where we have minus 5 meters per second squared times the time squared. And so if you square the time and multiply it times minus 5, that's going to give you your y position. For our velocity, let's see. Our velocity is going to change minus 10 meters per second each second. So we can use that information to solve for what our velocity ought to be at each point in time. So if we refer back to our front cover, then our velocity is going to be equal to the initial velocity, which was 0, right, for a dropped object. And then we're going to add the acceleration times the total change in time there. So keep that in mind for this guy. And so if our initial velocity is equal to 0, then all we're looking here for final velocity is our acceleration times our change in time. So anyway, so you're going to use that to figure out what the change in the vertical position is. And then here it says, suppose you could turn off gravity. When you throw the ball horizontally from the cliff at 30 meters per second, it would travel 30 meters for each second in a straight line. And then you're going to mark those positions. And so you're actually going to need another column here for your x position. And to do that, just like was on our front cover, our change in position is equal to the velocity in the horizontal direction times time. And our velocity here is going to be 30 meters per second times the time that has passed. And so that's going to give you your x position. And then when you have your x position, whoops, let me draw this down. When you have your x position and your y position, you're going to use those as coordinates on this page. And I believe, yeah. It's not. Sorry about that. Thank you for letting me know. Can you see it now? Yeah. Okay. So like what's weird is you guys can see my screen, right? Like it doesn't actually show me my screen when I'm presenting. Yeah, go ahead. Move the what? Oh, sorry. Okay, sorry about that, Zane. I didn't realize that it wasn't showing my screen. We have that fixed now. Okay, so what you guys are gonna do on this side, let me think for a second. Yeah, okay, so this is set up So that 1 centimeter is equal to 10 meters. So what you're going to do is if you make a calculation that says you need to move 10 meters, that's going to be 1 centimeter on this page. Does that make sense? Have you guys done scale drawings before? Or is this kind of new? Kind of new. Okay. So I'm going to give you guys the whole period to work on this. And it's okay with me if you guys work together on it. If you have any questions, especially Zane, if you have questions, since you couldn't see my screen, please let me know. If you don't have a ruler, I've got a bunch of rulers up here you could borrow. Just be nice to them. So my request would be, don't peel the cork off the back. Don't use them as weapons. Don't chip the table with them. Be responsible with them. Yes, Sam. Yeah, and this is just one right off that front page. So if you look at the front cover, that's where all these come from. So that's just our one horizontal equation. That's all that is. All right, you guys ready to get started?